The division property tells us that dividing a value by 1 results in the same value. More precisely, a divided by 1 equals a. Here are some examples. 5 divided by 1 equals 5. 3 plus 6 divided by 1 equals 3 plus 6. And x divided by 4 divided by 1 is equal to x divided by 4. The result of dividing 0 by a number is 0 as long as the number is not 0. More precisely, if a is not 0, then 0 divided by a equals 0. Here are some examples. 0 divided by 5 equals 0. 0 divided by 3 plus 6 equals 0. And 0 divided by 3 minus 1 is also 0. The result of dividing a number by itself is 1, as long as the number is not 0. More precisely, if not a equals 0, then a divided by a equals 1. Here are some examples. 5 divided by 5 equals 1. 3 plus 6 divided by 3 plus 6 is also 1. Finally, 3 minus 1 divided by 3 minus 1 is also 1. Dividing by a number is the same as multiplying by a multiplicative inverse of that number. More precisely, a divided by b is equal to a times 1 divided by b. Here are some examples. 5 over 7 equals 5 times 1 over 7. 1 plus x divided by y is equal to 1 plus x times 1 divided by y. M times n divided by 2 is equal to m times n times 1 divided by 2. Let's prove the following theorem. If a times x is equal to a times y, and a is not 0, then x equals y. The multiplicative property of equality allows us to multiply both the left and right sides by 1 over a. This is the same as dividing both sides by a. Since a divided by a is 1, the equation becomes 1 times x equals 1 times y, which simplifies to x equals y. Let's prove the following theorem. If b is not equal to 0, then a divided by b times c times b is equal to a times c. First, we show that a divided by b times c times b, or the left side, is equal to a times 1 over b times c times b. Then we use the commutative and associative properties to reorder some of the terms on the right side. We move 1 over b to the front, and we move a to the third term. Then we show that 1 over b times a times c is equal to 1 times a times c, because 1 over b times b is 1. Then we simplify the right side. 1 times a times c is equal to a times c, because 1 times a is a. Finally, we use the transitive property a few times to reach our conclusion. Let's prove the following theorem. S times 1 over 4 equals s over 2 times s over 2. We know that 1 over 2 times 1 over 2 equals 1 over 4. Thus, we claim that s times 1 over 4 is equal to s times 1 over 2 times 1 over 2. Finally, by rearranging the terms, we can show that s times 1 over 2 times 1 over 2 is equal to s over 2 times s over 2. Let's now turn our attention to fractions. Fractions are actually equivalent to divisions, so we are actually just extending our discussion on division a bit more. But at times, we will write fractions slightly differently for clarity. For example, 2 divided by 3 can also be written as 2 over 3. Let's prove the following theorem. If a is not 0, b is not 0, and a times b is not 0, then 1 over a times 1 over b is equal to 1 over a times b. For clarity, here's the conclusion in fraction notation. This theorem states that when we're multiplying fractions and the numerator is 1, then we can just multiply the denominators. This proof multiplies both sides of the equal sign by a times b, and shows that both sides become 1. This means that the two sides are equal. The proof then divides both sides by a times b to reach the conclusion. Let's prove the following theorem. If b is not 0, d is not 0, and b times d is also not 0, then a over b times c over d is equal to a times c over b times d. For clarity, here's the conclusion in fraction notation. This theorem states that when we're multiplying fractions, the numerator is the product of numerators, and the denominator is the product of denominators. Before you read the proof, we encourage you to try to prove this theorem on your own. This proof begins with the following theorem. 1 over b times 1 over d is equal to 1 over b times d. The proof multiplies both sides of this equation by a times c. It then shows that the left side is equal to a over b times c over d, and the right side is equal to a times c over b times d. Let's prove the following theorem. If a over b is equal to c over d, and b and d are not 0, then a times d equals b times c. For clarity, here's the condition in fraction notation. This theorem says that the product of the left numerator and the right denominator is equal to the product of the left denominator and the right numerator. In the proof, we first multiply both sides by b. Then we show that the left side reduces to a. Next, we multiply both sides by d. At that point, the left side is a times d. Then we show that the right side reduces to b times c.